Hi, I am Jayakumar, Department of Mechanical Engineering. I am an assistant professor. So, today with the topic discuss about the engineering materials and metallurgy, and particularly it focusing on hardenability. So, the hardenability plays a major role for the especially most of material science. So, particularly if you are increasing the based on it's slightly different from the hardness to hardenability now. So, hardness is a measuring about the resistance of the deformation, but if you talk about the hardenability, it is a process to become how much of harden in the depth of condition now. So, the hardness is a measure of resistance to the plastic deformation, but the hardenability is a case of hardness with attain the depth of directions of the objects. So, it is also measure about the uniformity of hardness. So, the determination of hardenability, we have generally two categories now, Grossman method and one is Jaume and quench test method. So, the Jaume and quench test method is the most commonly using for hardenability material science. So, in that condition Jaume and quench test was developed by Jaume and Birchwold. So, in the year of 1852, and this will be ASTM standardization will be done. So in that Jaume and quench test, we have the bar, we have to heat it, we can heat it conditions, we can transfer from an 100% of austenite and then quench it directly by the steam waters. So, this is a setup for Jaume and quench setups, and another ASTM standard of A225. So, ASTM means for American Society for Testing Materials. In that condition, first you have to prepare the specimen at the dimension, the diameter of 25.6 mm and the length of 104.6 mm. For example, we can take the steel 1018 steel. In that condition, we have to heat it about the 925 degrees Celsius for initially. So, the Jaume and quench test, this is a setup for the Jaume and quench setups, and we have a jet height will be given 63.5 mm for the jet velocity, and we can use the adjustment, maximum adjustment is 63.5. So, the flow from the orifice from base to above one. So, in that support we can talk about the specimen, we already mentioned diameters, and we have the gap between the specimen and then velocity jet, we can maintain the 12.7 mm as per the dimension of ASTM. So, in that you can see the specimen for that while holding at the specimen at the vertically in the setups, and we can apply the water flow at the base of the setups now. So, the water will be flow above gradually, so it will forms a quenching process will be started. So, in that cooling rates we can talk about the specimen will be holded vertically, we can apply the water at the base one of the one end. So, another will be hold at the top of the system, top of the setups, while apply the water from the base. So, we can take the cooling randomly from base to top. So, the cooling rate will be gradually decreasing now. So, we can initially direct impact on the water from the one end and directly go from the cooling rate at the end. So, after that, so the specimen will be completely quenched condition, we can take the quenching scale here. So, if that cooling rates, the Jaume test does not change based on the composition one. So, we have the specific distance from that, each and every distance we can vary from the cooling rate. From the, for example, from the starts from 1/16 of inches, we will set the cooling rate about 315 degree. So, in the degree says it will be gradually while increasing the distance, at the same time we decreasing the cooling rate. So, up to maximum level 36/16 inches of Jaume distance will take the cooling rate will be reducing up to 2.2. So, the simultaneously while increasing the distance of Jaume dust, the cooling rate also decreasing. So, in that ordinary conditions, so the cooling rate of the varies throughout the length. So, due to that will directly impact from the one end to the another end now. So, obviously the contact of the lower end will be directed to the impact, and higher will be a very less cooling rates now. So it will vary from the hardness from lower to higher end. If the lower end will be a very high hardness, then from the topper end will come some very softer materials. So it is directly related to that. So while the distance of the cooling rate is increases with decreasing the hardness of the material. So the greater depth with which hardness penetrates the greater hardenability of the materials. So after finishing the setup, we can take it out the specimen. How we can use the first flatten the one of the rod platen, then we can measure the each and every gap interval to measure the indentation of hardness. By example, you can use a Brinell or Rockwell hardness. In the Rockwell hardness test, you can measure the each and every point from the entire rod now. So it will shows gradually. So while increasing the sliding distance, at the same time this shorts and hardness will be decreased. So it will show us first initially we can take the initial point of the direct impact of what it will shows higher hardness of 50 HRC. Now it will be continuously it will moving down. So up to certain limit we can starts to decreasing the hardness of the material. So we can identify that how the hardness will be transferred by with help of cooling rates. So next we talk about the heat treatment and particularly focusing on annealing. So first about what is meaning of heat treatment is the sequence of heating and cooling condition combination to prepare the properties of the material. So the various heat treatment processes are annealing, normaling, tempering and surface hardening. So in that annealing, first you talk about the annealing, it's also a heat treatment process. It improves the ductility of the materials. So they have various types of annealing processes there, but generally it's also a heat treatment process. So for example, we take it about the full annealing process. In the annealing process, we have heated above the critical temperatures up to 30 to 50 degrees Celsius of above the critical temperatures. Then it's stored down to the room temperature inside the furnace condition. So this process is called as full annealing process. We can show the carbon level condition as well as if you have seen the A3. So that's A3 is nothing but above the critical line condition. If you above the condition of A3 line, it's come to the critical condition. Above critical conditions, we get heated, then you cool down the room temperature conditions. So in that bright annealing conditions, so compared to full annealing condition, it will be slightly vary now. So now we have normal annealing and the full annealing process. After heat treatment, you take into the room temperature level inside the furnace, you can get cool down. That is a full annealing. Now we talk about the bright annealing. So to avoid the oxidation of the material inside the condition, so we can use the coating protection by use of inert gas. So the inert gas supplied inside the furnace condition to make the heat treatment, so to avoid the oxidation of the material. So in that inert gas composition of 50% of H2 and 10% of CO and 0.5% of CO2 and 1.5% of methane, and remaining will make it as a N2 conditions. Now we move on the box annealing. So it's a sealed packed annealing. So while making a heat treatment of material, it completely covered with the charcoal. So if we covered with the charcoal and chips of iron, we can maintain that complete heated condition. Now obviously the atmospheric level you can maintain the completely sealed one to avoid the oxidation of the materials. Now move on to the isothermal conditions. So the previous condition we have maintained only a upper critical temperature, then cool down to the furnace by room temperature condition. Now this isothermal we are making as two steps now. First we maintain the upper critical temperatures, we are making some holding time for to convert into Ashnay stage. Then again you need to reduce down to the lower critical conditions. So there will be again you maintain the some time to cool down the material condition. Then finally you cool down to the room temperature with help of inside the furnace you can maintain all the cooling process after heat treatment. So this is the condition I told that. So first you making a upper critical temperature, you had heated above the critical temperatures. After hold on sometimes, so we can maintain, for example, we could take it out already 1018 steel. So we can heat it around 925 degrees Celsius. So above the critical temperatures you can maintain it. Then we can hold on some time to transfer into the Ashnay stage. Then we can cool down to the lower critical temperatures. So once the lower critical temperature to hold down, to remove the inside any martensite will be the former, you can remove the faces. Then we will remove the directly maintain the room temperature condition to cool down the air medium. So then we talk about periodized annealing. So the name of periodized is nothing but a circular oriented now. So we have a cementite in the metal matrix shows, so that is called as periodized annealing. So this is also heat treatment process, same annealing. So we will heat it, but inside the faces it shows the circular objects now. The circular object is nothing but a periodized. In that circular we can show a cementite will present in the ferrite matrix. So it is called as periodized annealing. So in the periodized annealing, I told that based on the shape you can mention the periodized annealing. During the long holding time, the cementite will be added to the cementite will be present in the ferrite matrix. So that will called as a periodized annealing. So in that annealing conditions we have to heat at the lower critical temperature above the long time, then cool down to the room mediums. Now move on to the subcritical process. So the subcritical annealing process we have three categories there. First one is stress relief annealing, recrystallization annealing, and third one is process annealing. So these are three annealing process involve the subcritical conditions. So first we talk about the subcritical annealing. So we got material had heat at 500 to 550 degrees Celsius. At the time you can maintain the temperature, maintain the same temperature up to 1 to 2 hours, then cool down to the room air condition. To this stress relief condition, to removing the stress without affecting of the hardness of the material. So next one is we talk about recrystallization annealing process. In that recrystallization annealing we can slightly increase from the temperature compared to stress relief annealing. So we can take it out 625 degrees Celsius to 675 degrees Celsius. We can heat it above the recrystallization level. So in that recrystallization level, the ferrite recrystallize and cementite tries to form the periodized conditions. So in that process, after heat treatment condition, we cool down to the room temperature air. So next one is we talk about the process annealing. So in that process annealing condition, we can take it to the above the recrystallization temperatures. So first we take the stress relief annealing is the below critical temperature, then we move on to the 625 degrees Celsius. Now move on the process annealing. So in that process annealing we can take it above the recrystallization temperature. So while heating above the recrystallization temperatures, we can form the phases, all the phases in form the to recrystallize and to form the uniformity of the material. Then you can cool down to the air medium to settle down all cementite and ferrite into the stable state. So this is the purpose of annealing. First you talk about the annealing process, what are the important conditions, we talk about various annealing process now. Now what is the purpose of annealing will be there. So in the purpose of annealing, to improve the especially hardness of the materials and to remove the stress inside the material, as well as to refine the grain size of the material and to making the homogeneous of the chemical composition. So these are the purpose of to making the hardness as annealing process, and we are making application, we can use the ball bearing, high carbon steel. These are the application for the annealing process. So we discussed about the first, we talk about the hardenability, and especially then go for the how to measure the hardenability by using of jamming and quench test method. Then we move on the annealing process, we have the various types of annealing process we discussed, and now what is the purpose of annealing. So these are the we did this video lecturing. Thank you.